So let's say that we are studying the 1936 presidential election. Let's go back in time. And the candidates for that election were Alf Landon and Franklin Roosevelt. So let's suppose that you are the editor of a magazine, let's say something like New York Times, and okay, it's not working. I'm just going to have to start it again. Okay, so let's suppose that you are the editor, and then you want to know, or you want to run a poll on voter preference in this election, and you need to know if voters prefer Landon or Roosevelt. So what's the first thing that you do? Well, the first thing that you do is that you have to gather data on voter preference. So let's say you have lots of money and you select 20,000 voters and ask them to fill out surveys, right? And so so the question then becomes is, how do you design your service for this study? You need to design your service in an appropriate way, okay, so that your study is not biased. So all these polls we see during presidential elections, there are some which will be biased. The reason is, when they make their surveys, they intentionally make the surveys to favor a candidate that they like, okay? So it does happen. Everything, a lot of, how good your study is, how good your conclusion is, depends on how good your surveys are. Okay. So again, we're not going to study designing surveys. There is an entire course on designing surveys. So let's say you select 20,000 voters, and let's say you made an appropriate survey for them, which doesn't have any bias. And so in this study, what are the units? Well, the units are the individuals or the objects of interest. And what are the individuals who are of interest in this case? These are the voters during 1936. Okay, so those are my units. What's the variable that I'm trying to study here? Well, the variable is, variable is a what? Variable is a characteristic of the units, right? So what variable am I trying to study here? That's their voting preference, right? Voting preference. And what is a measurement? A measurement is a value of the variable, right? A measurement is a value of the variable for one individual or one unit. So in this case, what is my variable, remember, is voting preference, right? And what are the values of this? What are the values of this variable? Well, I might prefer Landon, I might prefer Roosevelt, or I might prefer none of them. So there are three possible values of this variable. Is everybody okay? A measure, so what's the variable here? The variable here is the voting preference, right? A measurement is a value of the variable for an individual. Okay? For each voter, right? Each voter has a preference, right? So a measurement is basically what's the preference of an individual voter. Okay. So remember, you picked a here the population would be collection of all measurements, right? Or for all voters. And if you look at the population, it looks like what? it basically looks like bunch of, so for every, so imagine that you have the list of all voters, voter 1, voter 2, voter 3, voter 5, and so on, all the voters. For each voter, you have the corresponding value for his preference, right? So the population is basically a bunch of L, R, none, L, R, none. Am I making sense? Their preference. So that's the population of measurements. Sample would be a sub-collection or subset of the population. And remember, we picked 20,000 voters, right? Hypothetically 20,000 voters. So if you look at the sample data, how does the sample data look like? The sample data basically looks like a bunch of L, R, and none, right? L, R, and none. So you just basically have a list of L, R, and none. So that will be the 20,000 of them, right? 20,000 of them. That will be your sample. Now you have to infer something about the entire population from the sample, right? So in this case, how are you going to organize your data? Right? You collected how many measurements? 20,000 measurements, right? That's your sample data. Once you collected the data, 20,000 preferences, right? That means you have 20,000 L, R, or nones, right? Now your raw data is just a list of L, R, and none, 20,000 of them. Right? We have voter 1 up till voter 20,000, voter number 20,000, and then for each one you have its preference, L, R, or none. And so the question then is, how are you going to organize? If you give me that, right? If I give you a paper where I have 20,000 preferences and I give it to you, can you find out anything from that? Can you look at that and say something about the study? No, it's just a bunch of L, R, and F. So how should you organize your data in this problem? Well, what you want to do is you want to come up with the frequency of each value. So remember, in this case, the variable is preference. It has 3 values, L, R, or none. So I have 3 categories, right? And so I'm going to count how many voters in my sample preferred L. That's the frequency of this category. So the category L, right? Category L is, this is the category where, the preference is Linden. And how many voters, so that's the frequency of this category. How many voters prefer Linden? Same way, how many voters prefer Roosevelt? So this is the frequency for the category R. And then the category none would be there, let's say 3,000 voters said none. So if I add up the frequencies, I should be getting what? 20,000, because I picked a sample of 20,000 voters. So if I add up the frequencies, I should be getting 20,000. Now, for each category then, what I did is I looked at the relative frequency, or percent. What is the relative frequency? Well, I divide the frequency of each category by the total frequency, by the total size of the sample. So 8,000 divided by 20,000, that's 0.4, which means 40% of the voters prefer Linden. And then if I divide 9,000 by 20,000, I get 0.45 or 45%. So that means 45% of the voters prefer Roosevelt and 15% prefer none. Is everybody okay? So now, instead of giving you the raw data, which is a list of bunch of L, R, and none, if I give you this table, doesn't that tell you a lot more about our study? So this is one way. So in this table, we are basically organized the data, and we actually summarize the data. It tells you, it gives you a quick understanding of what happened. So, any questions on this? Now, I can also graphically represent this table. So how am I going to graphically represent this table? Again, relative frequency tells you what? This is the proportion of sampled voters who prefer Landon, right? 0.45, that's the proportion of sampled voters who prefer Roosevelt, right? Is everybody clear? That's the meaning of relative frequency. How am I going to graphically represent this table? Well, I can use a bar graph. So what is a bar chart? It's you can also call it a chart. I can use a bar chart for this to graphically represent the data. So what is a bar chart? Basically, what you do is that the vertical axis, you use that for relative frequency or just the frequency if you want. And you can use, so what you do is that you're going to use a rectangle for each category. Here I didn't write down the other category. I only wrote down the two categories R and L. Okay, and so for each category, I represent each category by a rectangle. All the categories will have the same width. So all these rectangles have the same width, but the height of the rectangle is the relative frequency of the corresponding category. So remember, for Roosevelt, right, what was the relative frequency? 0.45. So 0.45 is right about here. So the height of this rectangle is 0.45. Right? The widths are the same. So you can pick the width to be 1 or 2, whatever you want. And then for Landon, the height is 0.4. That was the relative frequency. So I can use a bar graph like this to represent the data. Now, if you look at this bar graph, you can get a quick understanding of what's going on. Right? Quickly, you can say that, hey, the 40% of the voters prefer Landon. Right away, you can say that 45% prefer Roosevelt from this graph. Right? So this would be the graphical representation of the data. And this is called a bar graph or a bar chart. Is everybody clear how to create a bar graph? You use the same width for all the categories, and for each category you represent each category by a rectangle. The height is the relative frequency, or you can just use the raw frequency if you want. You can just use the frequency instead of the relative frequency if you want to. Okay, so what prediction then can you make from this study then? From your sample, you found out 45% prefer Roosevelt and 40% prefer Landon, and then you say, well, I think Roosevelt's going to win, right? But if you say that Roosevelt's going to win, should anyone believe you? Well, if you want to, so you are trying to conclude that Roosevelt is going to win, right? That's what you want to predict, right? But how much confidence? What's the degree of confidence you have when you say that Roosevelt's going to win? What if, let's say, what if you can say that 95% of the samples? So remember, you picked a sample of size 20,000, but there are many samples, right? If I want to pick a sample of 2 students from this class, right? there are many samples. There isn't only one sample of 2 students, right? I can pick 2 students in many ways. So there are many samples of 2 students here, right? Same way, there are many samples of 20,000 voters, right? So think about if I can say that 95% of the samples, if you look at all the samples of size 20,000, and I'm saying 95% of them will produce the same proportion, that we got up to 1.2%. Does that make sense? So if I look at 95% of the samples, right? Almost all, okay, 95. If I look at all the samples of size 20,000, 95% will give me the same answer that I got, up to 1.2%. So my answer might be wrong, plus or minus 1.2%. But that still means that Roosevelt is winning, right? So this is the degree of confidence we have in my number. So I'm saying I am 95% confident that Roosevelt's going to win because, okay, my error is still makes Roosevelt winning. Does that make sense? All right, so we'll see that this part later in the course. Right now, what is important in chapter 2 is for you to understand how you make a bar graph. So if I give you a bar graph, can you from that bar graph, can you understand the bar graph? What is it telling you? That's the focus that you're gonna have right now. Okay, so what is a bar graph then? A bar graph is also known as a bar chart. Sometimes it is also called a Pareto diagram. But I want to say though, if you have a bar chart, right? A bar chart or a bar graph is a diagram with rectangles, right? Now, if you arrange the categories so that the rectangles are in decreasing order of height, that's when you call it a Pareto diagram. In my previous example, remember, if I switch the categories like Landon and Roosevelt, then I get increasing height, right? But the way I did it, Roosevelt first and then Landon first, second, I got decreasing height, right? That's a Pareto diagram. So if you have a bar graph with decreasing height of the rectangle, that's a Pareto diagram. So not a big difference, but this is used for categorical data, and it can also be used for a quantitative variable with few values. So if I have a quantitative, remember I said, if I have a quantitative variable, but it has only, say, 5 values, then I can think of it as a categorical variable. I can think of dividing the population into 5 categories. Well, I think I should stop here, and we'll just we basically started chapter 2, but let's pick up from here tomorrow. Any questions?